Hello. We are looking at notes 2.4 today, which are on factoring. This is our second day of factoring. And we have one last thing that we have to learn, which is factoring differences of perfect squares. And then after we're done with that, we can consolidate everything and learn how to factor completely. So here are the notes on factoring differences of perfect squares. All right, now we're going to talk about differences of perfect squares, but before we do anything at all, I just want to go through and remember how to multiply 2x minus 5y by 2x plus 5y. So we can FOIL this, right? So I'm going to multiply 2x by 2x, and I end up getting 4x squared. And I don't need brackets. So I end up getting 4x squared, and then 2x times 5y ends up giving me positive 10xy. Negative 5y times 2x is negative 10xy, and then negative 5y times positive 5y gives me negative 25y to the power of 2. And then what ends up happening is this term and this term are identical except for their signs, so they're inverses of each other actually. They cancel each other out. We end up getting 0. There's no middle term there at all, and I end up getting 4x squared minus 25y squared. And this is an example of a difference of perfect squares. So whenever you have a difference of perfect squares, the factoring method is exactly the same. So if I have a squared minus b squared, it's just going to be a plus b multiplied by a minus b. Again, you can switch these two terms if you want to. The order doesn't matter as long as what's inside the bracket stays the same. Okay? So how do I tell if something is a difference of perfect squares? Well, it has to follow this checklist right here. It needs to be a binomial. It needs to be two terms. So here I've got one term, two terms. It's a binomial. Here I've got one term, two terms. It's a binomial. It has to be difference. It has to be subtraction right here. One of the terms must be a negative. If they're both positive, it does not work. And the reason why is because in order for this term and this term to cancel each other out, one has to be positive, one has to be negative. But to get these two terms, we're doing some multiplication, which means that one of these terms also has to be positive, the other one has to be negative, meaning that one of these numbers here has to be a negative value. So they cannot be the same sign, basically. Okay? And then finally, both terms have to be perfect squares. So let's look at some examples, and then we're going to look at some non-examples. So how do I tell if something is a difference of perfect squares? Again, I follow this checklist. So let's see, is this a binomial? Here's one term, here's a second term. Yes, it works, so it satisfies my first condition, so I'm good to go for the first condition. Okay, is there one positive and one negative? Absolutely, it's a difference, so it works. And then are both terms perfect squares? Well, 6 times 6 is 36. X squared times x squared is x to the fourth, so that works. 7 times 7 is 49. And here, a lot of people get to this point and think it's not a perfect square because it's y to the 10th power. But don't forget, I don't need to look for the square root of 10. I need to look for what times itself will give me y to the 10th power. And I can do y to the 5th times y to the 5th. So I know that it's perfect. They're both perfect squares. Since it satisfies all of my conditions, I'm good to go. Now, right here, remember, we said that it has to be a squared minus b squared equals a plus b times a minus b. So we know right here that this first term right here has to be 6x squared, and this first term here has to also be 6x squared. And then this last term right here tells me that my final terms, sorry about that, are going to be 7y to the 5th power and then another 7y to the 5th power. One is going to be a plus, one is going to be a minus, and that's my answer right here. So I can circle this and say this is my answer, but I want to confirm that it really works. So when I multiply 6x squared by 6x squared, I end up getting 36x to the 4th power. Right? And then when I multiply 6x squared by this negative 7y to the 5th power, I end up getting minus 42x squared y to the 5th power. Then when I multiply my inner terms together, I get positive 42x to the second y to the 5th, and then when I multiply my final terms together, I end up getting, my last terms, excuse me, I end up getting minus 49y to the 10th power. These will always cancel each other out, so I know that it's the right answer. Again, don't circle this right here as your final answer. This is just a check to make sure that it was all correct, okay? This is our final answer. Okay, so let's do another check for this one right here. Why is this an example of a difference of perfect squares? Well, it's a binomial. There's one positive, one negative, so it's a difference, okay? And then both terms are perfect squares. Absolutely. X to the 8th, I can square root. 81, I can also square root. So let's go ahead and try this. So I end up getting x to the 4th power, or x to the power of 4, plus 9, because x to the power of 4 squared is x to the power of 8. 9 squared is 81. And then same thing here, it's x to the power of 4, but it's minus 9. Okay? And normally we would say we're done, but we're not. Now this first expression right here is the sum of perfect squares, and at this point in time you don't know how to factor that, so we're just going to leave it as x to the 4th power plus 9. It's not possible using real numbers. And then over here, I can factor this further. This is another difference of perfect squares. So I'm going to go ahead and factor this even more. So I'll color code this so you can kind of see it and understand what goes with what. So right here, x to the 4th power, when I square root it, I get x to the power of 2. And then 9, the square root of 9 is 3. I can put a plus sign and a minus sign, and then I can't factor these any further because this is a sum of perfect squares. This is a sum. I don't even have perfect squares because 3 is not a perfect square, and this is a difference of some terms but not a difference of perfect squares. So this will be my final answer. Okay, now why are these some non-examples? Well, in this first one right here, it's definitely a binomial, but it's not a difference. So this is a sum of perfect squares. And again, we just talked about this right now. You cannot factor it using real numbers. Okay, and then over here, let's double check to see why this one doesn't work. Well, it is a binomial, check. It is a difference, check. When I look at this, when I first take a glance at it, it looks like all the terms are perfect squares. However, this right here is not a perfect square because you can't get two numbers that will multiply together to give you x to the power of 5 using integer exponents. The closest you can get is x to the power of 2 and x to the power of 3, which are not identical, so it does not work. And that's why this is not a difference of perfect squares, and it's not factorable. Okay, we're going to go ahead and talk about factoring completely. And when you factor completely, you need to ask yourself several questions, and make sure you have these questions written down and memorized, because knowing these questions will help you to factor correctly. Okay, so here's your list of questions you'll need to ask yourself. First of all, is there GCF? Is there something in common with all of my terms? Now, the GCF could be in the coefficient, it could be in the variables, or it could be in both. Okay, then I'm going to ask myself, is it a difference of perfect squares? And remember, we just listed out 3 conditions that we need in order to have a difference of perfect squares. We need to have a binomial, or 2 terms. Okay, we need to have subtraction, and we need to have perfect squares. Remember, you cannot factor a sum of perfect squares. It's impossible. Okay, and then I'm going to ask myself, is it a trinomial that I can factor? So we could either do guess and check, or we can do decomposition if you prefer. Okay, then you're going to ask yourself, can I factor by grouping? Generally, when we factor by grouping, we have 4 terms. Okay, it doesn't necessarily mean we always have 4 terms, but generally we'll have 4 terms, and then you can group 2 terms together and pull out something in common. Okay, and then lastly, you're going to ask yourself, is it completely factored? Okay, so let's go ahead and apply this to this question right here. You don't have to rewrite the list of questions because hopefully you have it in your notes, and we're going to do this example here. So the first question I'm going to ask myself is there a GCF? Is there a greatest common factor? So looking at both of my terms, I'm going to look at my coefficients first and see, is there a number that I can divide 50 and 242 by? Yes, there is. That number is 2, so I'm going to factor out a 2. Then I'm going to look at my variables and see, is there anything in common with my variables? And there isn't, so I'm just going to factor out the 2. And when I divide it out, I end up getting 50x squared divided by 2 gives me 25x squared. And here I get minus 121y to the power of 4. So I'm done with the question, is there GCF for right now? Okay. Then I'm going to ask myself, look at what's inside of here, and I'm going to see, is that a difference of perfect squares? Well, it's a binomial, so check. I got 1 out of my 3 checks. There's a subtraction sign right here, so I've got 2 out of my 3 checks. And then 25x squared is a perfect square, and 121y to the power of 4 is also a perfect square. So that means that I can factor it as a perfect square. So remember, the square root of 25x squared is 5x. So put 5x and 5x here. And then the square root of 121y to the power of 4 is 11y squared. 11y squared here. Then I'm going to put a plus sign and a minus sign here. So I factored the expression inside right here, but I still have a GCF, so I need to make sure that I bring that 2 down, okay? So I'm done with the next question. Is it a difference of perfect squares? Now I'm going to look and see, is it a trinomial I can factor? So right now, if you notice, I have 1, 2, 3 different terms. So I'm going to look at each term separately and see if it's a trinomial I can factor. Well, 2 by itself is not a trinomial. 5x plus 11y squared is not a trinomial, it's a binomial, and 5x minus 11y squared is also a binomial, so it's not a trinomial I can factor, so I'm done with this step for right now, okay? Then I'm going to see, can I factor by grouping? Same thing, looking at each term separately, they don't look like they're going to be factoring by grouping, so that's not going to work at all either, okay? And then I'm going to ask myself, is it completely factored? So can I factor this 2 anymore? No. Can I factor this 5x plus 11y squared anymore? No, because if I go back through my list of questions, there's no GCF and it's not a difference of perfect squares, and we already asked ourselves these questions about what's inside of here. Same thing with 5x minus 11y squared, so this is going to be my final answer. And remember, if I multiply this all through, I should get this answer that we got originally, okay? All right. Our next example is going to be c cubed minus 2c squared minus 35c. So first question, is there a GCF? Well, looking at my coefficients, I have a 1, a negative 2, and a negative 35. There's nothing in common with those 3 terms, so the coefficients don't have a GCF. But looking at my variables, they all have c's in them. So my GCF is going to be c, okay? And then when I factor c out of c cubed, I get c squared. When I factor c out of negative 2c squared, I get negative 2c. And when I factor negative 35c, factor the c out of there, I get negative 35, okay? And remember, if I were to distribute this through, I would end up getting this expression up here. So I'm done with that part. Next part, is it a difference of perfect squares? Well, looking at what I have here, it's not a binomial. There is subtraction, but I don't have perfect squares. So it doesn't satisfy all 3 of my conditions, so it's not a difference of perfect squares, okay? Next thing I'm going to do is look and see inside of here, is this a trinomial that I can factor? So I do have a trinomial here. And if it was a trinomial I could factor, I would have to do some guessing and checking, okay? So I know that the first multiplied by the first should give me c squared, and I know that the last multiplied by the last should give me negative 35. So I'm going to think of factors of 35, so I'll try 5 and 7. And this here gives me 5c, this here gives me 7c, so I get the negative 2c I want if the 7 is negative, and I have a positive right here. Okay, don't forget to copy down that GCF when you're done. Okay, so it was a trinomial I can factor. I factored it, so I'm done with that step. Then I'm going to see if I can factor by grouping. Well, looking right here at the c, there's nothing that I can factor by grouping here. C plus 5 doesn't look like I can do that either, and C minus 7 doesn't look like I can do that either. So I'm done with, I can't factor by grouping, so I'm done with that piece. Now I'm going to ask myself, is it completely factored? If it was completely factored, I should be able to go through this list again and have no as my answer to all of them. So C plus 5, and C minus 7. Is there GCF in any one of these 3 factors? No. Is it a difference of perfect squares for any of these 3 factors? No. Is it a trinomial that I can factor for any of these three factors? Nope. Can I factor by grouping? Nope. So is it completely factored? Yes. So this is my final answer. Okay? All right, the next question that we have is the quantity m squared minus 2m squared minus 18 times m squared minus 2m plus 45. I'm going to go through my list of questions. Number one, is there a difference of perfect square, or sorry, is there a GCF? Is there anything in common with any of my terms here? No, there isn't, so we're done with that question, okay? Next question is it a difference of perfect squares? Well, I have one term here, a second term here, and a third term here, so it's a trinomial. I have an addition sign, and I don't have perfect squares. So those are three reasons why it's not a difference of perfect squares, okay? So I'm done with that question. Then I'm going to ask myself, is it a trinomial I can factor? Again, same thing, I have three terms, so it is a trinomial for sure, but it looks pretty complicated. So I'm going to make my life a little bit easier, and I'm going to let u equal m squared minus 2m. Well, if u is m squared minus 2m, then my new expression can say u squared minus 18u plus 45. So it is a trinomial that I can factor. So when I factor it right here, I would put u and u because u times u is u squared, and I'd look for factors of 45 that add up to give me negative 18. Remember, when my coefficient here is 1, it's a lot easier. I don't have to do as much guess and check. So I'm going to try 15 and 3, and I know this gives me 15u, and I know this gives me 3u, so I get the 18u that I want, but I want it to be a negative 18u, so this should be minus here and minus here, okay? Now that I've done that, I'm going to go back and I'm going to replace my u with what u is equal to. So right here, I'm going to have u squared, instead of u squared, here I have u, so instead of u, I'm going to put m squared minus 2m, okay, that's what this u is here, and then I just am going to copy down the minus 15. Okay, and then in my second set of brackets, same thing. I still have another u here, and I know u is m squared minus 2m, so I'm going to say m squared minus 2m again right here, and then I'm going to have minus 3. Okay, so now that I've done that, I'm going to see if I can factor by grouping. So looking at this right here, my first factor, I can't factor by grouping, and my second factor, I can't factor by grouping, so I'm done with that, okay? Then I'm going to ask myself, is it completely factored? So I'm going to go through my list again, and I'm going to ask these questions about each individual factor. So is there a GCF in my first factor? No. Is there a GCF in my second factor? No, again, so there is no GCF, so I can cross that off, okay? Is it a difference of perfect squares? Well, I have a trinomial here and a trinomial here, so it's not a difference of perfect squares, so I'm done with that question, okay? Is it a trinomial that I can factor? Well, again, here, my first factor is a trinomial, and I think I can factor it, so let's try our first factor right here. Remember, the first times the first will give me m squared, okay? And then I'm going to look for factors of 15, negative 15 that add up to give me negative 2. So I'll try negative 5 and positive 3. So this right here gives me negative 5m. This here gives me 3m, and that gives me the negative 2m that I want. So that's the first factor that I have here. Now for my second factor that I have, same thing. I'm going to go ahead and take a look at how I can possibly get some numbers to work out for me. So here, m times m gives me the m squared I want. I'm going to use 3 and 1 because those are the only factors of 3. If I use a negative 3 and a positive 1, that gives me the negative 2m that I want. Okay, so is it a trinomial that I can factor? Yes, I'm done with that question. Can I factor by grouping? Looking at each of my 4 factors that I now have, I can't factor by grouping. And then is it completely factored? I go through my list again. So looking at my 4 different pieces right here, is there GCF for any of these factors? Nope, so I'm done with that. Are any of these factors a difference of perfect squares? Nope, so I'm done with that. Is it a trinomial that I can factor for any one of these 4 factors? Nope, so I'm done with that. Can I factor by grouping? We already said we can't. So is it completely factored? Absolutely. And this is my final answer for this question. Okay?